In Simulation 2010, there's been a lot of effort put into improving the user experience and making it a lot more intuitive. First thing you'll notice is when we look at our study, we've got a change in the icons which now give a lot more visual feedback about the particular entities. So for example, here we can see those are clearly foundation bolts and that this is a bearing load. The other thing you'll notice is that as we move over the entities, we get tooltips which give you key information about those objects. Same thing happens on the screen, so wherever you are, you get access to that information readily. Also, simple double click is more reliably bringing up the modify capabilities as well, so it's easy to access information. With results, we now have the ability to clean up large numbers with a 1000 separator, so when working with Pascals, that makes life a lot easier. Also, we've added the ability to plot results in KSI as well, so for those working in English units, it gives you much more convenience. One of the things I would have liked last year with the bolt check plot capability is the ability to interact with multiple connectors and modify them in one hit. So I can now select all of these different bolts and modify them and apply properties to all of them in one go. This is a huge time saver so that we can effectively iterate through some design options quickly. So I can double check that, just click on one of these bolts. And we can see that the preload's 200. Also, we can add folders to structure our model to clean up the interface. So instead of having to navigate through a long tree, we can now pick all these connectors and just drag and drop them, or we can drag and drop a subset as well. So it really cleans up the interface and makes your model more manageable. Let's just go back and we'll start by showing you the new Simulation Advisor. They've made some great improvements here, and it follows a similar process to what you'll see in Simulation Express, where we have a logical workflow. And there's also a lot of links to online information and so on while we're working through here. So you can see we get a lot of checkbox options here about our study as we work through. Because we've got another study there, I think it's showing these checkboxes at the minute. But again, you start out by saying what you're concerned with, so stress. And in this case, we're not worried about deflection, we're more worried about stress. And we want failure in a particular location we're concerned with. And obviously this is going to initiate a sensor. So I'm going to pick and say I'm concerned with the stresses in this area here. And we could put an alert on there if we wanted to as well. Then it'll create the static study for us, and then we just continue on through the workflow. So now it's to bodies and materials, and it's going to ask us about representation. And it's got a lot of great information here, with examples of axis symmetric options for when you can do a subset of the model. Symmetry doesn't apply to us, so we're not going to worry about that. You'll see also that it talks about whether we represent things as solids for large three-dimensional objects, or for thin-walled objects representing them as shells, or weldments representing them as beams. So it's very convenient to get access to that information. There's a lot of information there about helping to define connectors as well. We don't have any, so I'm just going to skip that section. We don't have any material changes to worry about, so we won't worry about that. Then we get our introduction to interactions. So we can go in here and, like before, we can have a lot of information about contacts and all those other aspects. We're not going to worry about that in this instance. We're just going to straight in and add some support fixtures. And again, it launches all the dialogues for you, so it takes away that effort of having to know where to get information. We want to create more interactions, and we'll add a load. And we'll add it to that face, and we'll just put in 6,000 newtons there. Alright. So we're ready to run it. When you go to mesh settings, there's information there on aspects of mesh quality and everything else. We don't want to change any of that, but just wanted to show that to you. And we can run the study. And you'll see that we get access to the new meshing dialog where you get a memory consumption usage, and the new solver dialog as well, which is a lot cleaner without the DOS prompts. So you can see here we get access to our results straight away as we did before, but now we'll have a little bit more help in finishing. So we go to the results section, and by default it's seeing a scale of 1 for the deformation, so you're not going to see much when we animate it. But you see here that it can give you feedback about that. And if it's not correct, then it'll go through and give you suggestions on what to look for. For example, if the magnitude of deflection isn't correct, well, check the scale deformation. So again, common problems that people have, and giving them feedback on information on what to do. So everything here looks reasonable for us, so we're concerned about whether this is going to break or not. And it gives us access to those basic things to answer that question. So we've got factor of safety, so we can see we've got a minimum of 1.56. But like you would ask, is this accurate? So what it does is it talks here about trying to refine the mesh manually, or actually you can just launch the H-adaptive and rerun the study automatically, which is a great little tool for making it easier for people to ensure that they've got good results. This one's going to run a couple of runs, and you'll notice that the stretch doesn't change all that much, so it's already at a converged solution. And also we can look at other things. Let's just go back here to results. And under here as well, you see we can get access to see where the load path is, which is great. So again, it's putting a lot of tools at the tooltips, at the tips of the user's fingers, so that they can get access to information quickly and easily, and help them learn how to utilize the product more effectively.